Now, one of the things which we would like to show you is a demo of workflow for optimizing the TensorFlow model to TensorRT model using reduced precision, right? So here we are trying to actually show you the graph generation. Okay, so what would be the graphs looking like? Okay, so I will show you first the graphs which we generate, and then we will show you on that system. Okay, so this is basically trying to pull the containers. Then you basically use this, and then once you read a TensorFlow model, you convert to a frozen model, which is star.pb. Okay, this is what basically is a frozen model, and then you optimize that frozen model to a TensorRT graph, right? This is how you do it. You convert the frozen model to a TensorRT graph using TRT graph. Then you actually put TRT create inference graph, all of these parameters, right? And the precision mode, which we discussed, okay? And everything like that. And then you basically get this something like a TensorRT model is successfully stored, because we are printing it, because you are trying to store this model, okay? So this is how we actually, when you run, you get something like the TF graph, okay? What is the graph size? How many nodes? Okay, what is the graph size? Everything like this. We'll show you gradually of how actually it is optimized, and ultimately what you get in the end is something like this. Number of all nodes in the frozen graph is 46. Number of TRT engines nodes in the TensorRT graph is 2. We will see this, okay? And number of all nodes in the TensorRT graph is 13. So this basically means you are trying to correlate a model which you have actually got it from a TensorFlow, okay, to something which is optimized like this, okay. So how many nodes in the frozen graph? 46. Now what you do? You convert that into a TensorRT graph with how many nodes? 13. Okay, and how many engine nodes in the TensorRT graph? There are only 2. We will see what does it mean by engine node and what are various graphs. So where are various nodes in the graph? But this is how it is. So let us try to understand this. I hope at least on the Tensor board you would have seen these TensorFlow graphs, right? So this is how a graph for a TensorFlow program looks like. Okay, this is a classification program. You have input, you have a convolution layer with this size of a kernel. Then you have the ReLU activation, then max pooling, then again the convolution layer. All of this like this. This is the initial model. Like you have a flattened thing, you have softmax, okay, and then you have this output tensor. So input and output tensor, and this is the initial model. Okay. So now from this initial model, after those steps, you will get a frozen model. So this is how a frozen model is, right? So you get a frozen model like this, okay? This is converted, okay, this frozen model. And then I'm not going into the details, but as you go along, you can actually understand, right, which of these layers, okay, are like basically, finalized and frozen, right? So this and this is almost the same. The only issue is you cannot change anything in this. This is not trainable now, but this is trained model. This can be trained further, right? And then the next thing is that you get a TensorRT model, right? So this is how the TRT engine, okay, creator gets you this format. So this particular model, okay, has been optimized to this, wherein it uses fusing, okay, fusion of the layers, horizontal fusion, vertical fusion, everything happens. You get the tensor input, okay, the same way, and then you have this final output at the softmax layer. This is what actually is converted from a frozen model to a TensorRT model. We're not going into the details at present, but this is a very, very good detailed what to say content, okay, which basically requires you a very, very good understanding of how basically it has to be done if you understand the internal intricacies of the TensorFlow, the graph, okay, and all of that. So we are just trying to show you in a short time as to how everything happens, okay. So let us try to actually do some demo now of how everything is done. So let me just so basically we are going to import, okay, the TensorFlow model. This is how you actually import it, okay. So you are trying to import a model which is a small model, okay, and then you basically try to actually convert that convert that to a frozen model. So what you are trying to do is you are trying to actually generate a frozen graph, okay, from basically this. And if you see here, you will actually try to use the what to say, the frozen model, okay, is to be generated using a CPU, GPU, CUDA GPU executor, right? So here, what we are trying to do is we are trying to actually use a TensorFlow. We are trying to understand which NVIDIA GeForce GTX on which we are running, okay, on which device we are trying to convert it, and then we get a frozen model here, right? And when we try to optimize the frozen model to a TensorRT graph, okay, so this is a frozen model now. So we are just trying to understand and generate a TRT graph, okay. Okay, so we are going to create an inference graph, and this is how the thing is. My maximum batch size, what is the precision we are trying to do, okay, and then what is the input of to this particular graph definition. So this is a frozen model, right, which we have used. So we are using this frozen model in the previous step to generate a TRT graph definition, right? And from that we are trying to create an inference graph, right? So, and we are going to write it in a dot model pb file, okay. So if you see here, the TensorRT unsupported or non-converted, right, operations. As I showed you, there are certain specific supported conversion operations for TensorRT, as I showed you in one of the PPT slides. But now here, these are certain unsupported conversion operations, right? So total unconverted operations are 8, okay. Total unconverted operation types are 8, and total unconverted operations are 9, okay. So this is how basically it is to be understood. And then you basically try to actually, okay, understand, right, how is this graph size, okay, getting modified, right? So it is all linked to tensors and then the graphs, right? So this is how it's going to actually do. And then you basically ultimately, okay, see a tensor model which is successfully stored, and you can actually count, okay, how many nodes and how many operations were there before and after the operations. This is what I showed you in the slide as well. So number of nodes in the frozen graph is 46, number of nodes in the RT graph is 13, and then convert it to a tensor RT model. You can visualize this, okay. So this is just to make you feel, okay, that once it is actually optimized for inferencing, okay, how small the scale of the whole graph becomes, okay. And that is why the inferencing is such a serious issue wherein optimization is of utmost importance, right? So I hope this has made certain things clear on the part of how the optimization happens, right? So this is how the fusion happens. And when we run the program now, we will show you, right, how the optimization or how the fusion happens, right? It shows you step by step, okay. We'll try to show you that now. Before that, I'll just try to run one or two videos. In the meantime, we will set that up for you to actually see. Okay, so I'll run the videos, and in the meantime, I'll just set the camera also. So give me a sec, and I'll try to run the video which we actually showed you yesterday, certain applications. So today we again tried to do the same program run on a Tensor RT optimized program, okay, on our Jetson TX1. So if you see this, it's a very small program, right? It's not very what to say, done for a specific application, but these are all available online. We will give you the links so that you can also download and do. So it can detect multiple persons, multiple chairs, okay. Not very much using a very highly trained model, but okay, for some of the things, right, like suitcase and chair, it is showing. But okay, these are certain things which you need to rectify, but we are just trying to show you that, like, this is how it can be done on an inferencing edge device, right? So this is one thing which we uh, try to show you, and another one is wherein we are trying to do something of detection, okay, post detection. So this basically is a post detection program which we are trying to run with a inbuilt onboard camera of on Jetson TX1. So this is what we actually tried to do. So you have got a post detection, you have got classification, then you basically have a lot of other programs which are there, okay. So I suppose got stuck or something, but yeah, so something like this. So let me just try to run it, and 1 minute. Yes. So if you can see the monitor, which basically is connected to the Jetson TX1, what we are trying to do is, I don't know whether the resolution of the camera is good in a sense, but we have to enlarge it a bit. Let me check if we can enlarge it. 1 minute. Mhm. No, this is the maximum size. Let us see what happens. Okay. So yeah, somewhat it increased. Let me just check once again. No. Okay. So what we are trying to do is, now we are trying to run a DetectNet program, okay, for actually classifying, right, uh, people, okay, and chair and all of that, right? So let us run the program and then see what basically happens. Okay, image gets stuck, it seems. I don't know. Here we will have to actually convert it into video thing. Yeah. So if you're seeing this, you just convert. Okay. So here, if you are seeing this, that this 1 minute, it's a bit slow because of the lag, but the idea is that this is happening, uh, and then if we show you the conversion of things, no, the camera is not correct, so it's not actually showing, but I suppose it's visible. Yeah. So if we stop this, we can show you the scrolled history, and there you can actually see the fused layers and all of this. Let me just stop this and let me show you that. Show you, right? It's going to show you that merging the layers. Okay. After vertical fusions, there are 94 layers. After you remove the dead layers, right, there are 94 layers again. Okay. And how much auto tuning format combinations, right? All of this after concatenation removal, how many layers are left? Okay. So how many layers are left? And all of this is going to give you a fair idea of understanding. And after you actually merge the tensors, okay, how many layers are there? Okay. So this basically is trying to give you a understanding of how this mobile net program, right? Of course, this is a different program from the program which I just now showed, right? That was for DetectNet, and this I'm showing you for mobile net. But that actually also will do the same thing of merging, right? And fusion, and everything of this sort is going to happen. So in the beginning, what's going to happen is you will get something like this, right? Fusing convolution weights from feature extractor for that particular program, which particular layer, right? Convolution 11 layer. Then fusing convolution layer to then scaling the feature extractor with scaling and everything, right? So fusing convolution weights, and all of this are actually done for lot of things. Okay. So this is the next thing. So it is actually a continuous thing of trying to get all of this, right? So we'll try to show you another program which basically is using a, I don't know, it gets stuck again. Yeah. So it basically is a DetectNet program, okay, which you are trying to actually see here. The device is a GPU, it has loaded things, okay, and it's a bit slow, so it will take time. Yeah. Actually, the idea is I cannot do SSH onto it because the GUI issue is there. So I could not have shown you that. This basically is a post detection, right, which we are trying to do. And of course, we can do SSH onto it, and I can show you the running command after the GPU thing is over. So I just wanted to show you this uh, GUI stuff, right, the Windows stuff. Otherwise, it would have got stuck. So that was the reason I did not use the thing SSH and do it, because again it will create a lot of issues on my X server thing. So that was the reason I had to do something like this. So I hope it is understandable to some extent in such a short time as to how do you convert, okay, the program, a TensorFlow program, to a TensorRT program and utilize it on something like a Jetson TX1.